Hello everyone, welcome back to my channel. So in this video I'm going to show the practical implication of KCL. So in the previous video theoretically I showed how the KCL works and how the KCL is used. So if you've not seen that video, that's okay, but in this video you will understand very clearly what is KCL and why it is used and how it is used. So let us take some components for to show that, and I will make a very simple circuit that you could understand very easily. So let's press P in the keyboard. Why it's not working? We will go here. Let's search the register. Okay, let's take it. We'll take totally three resistors. I will make very simple circuit. And now I will take a voltage source. DC voltage source. Okay, this one I will take. And I will use one here, one here. Two voltage sources I will use. Okay, let us connect this whole circuit. We have to change the values. I will change it. Like this. You can try it on your own in the Proteus. Proteus is a very useful software. I suggested to download because it shows the practical, because every time we cannot sit with the breadboard and do all the circuit, because sometimes you don't get the resistors values you want. So I preferably use this to teach. That also I will do one day. Whatever the components I require to take, I will take it and do it also one day. That's also is there, because that's a different thing when we do it on the breadboard, because in the breadboard results are different than the practical results. So this is 1 volt and this is also 1. Let it be. I will make the resistor values as 1 ohm to make it simplify. Actually, use of this Proteus software is it gives every components you require to do any circuit. And one more thing, there is no loss of anything. If you do, that's not allowed also. Means sometimes what happens, you can't give a particular voltage to a resistor. There is something called as a ratings of power. If you not see the power ratings also in the Proteus, that's not a problem, because it is not going to burn anything here. So you can do anything in the Proteus. That's what my motto of telling. Okay, let me take one ground and put it here so that this side this becomes a reference. So in the previous video I have told, whenever we see a node, it has to connect it with the one more than two components. So how many nodes are there in this circuit? We can say we can see two nodes. One node is this and one more node is this. There are two nodes totally we can consider. As we can see here, there are no any other nodes. If you see, this is not a node, because I have said what has to be the node. The node has to be the place where more than two elements has to be connected. That's what the node. So here only two elements are connected, so this is not a node, this is not a node, only these two are node. Means here the node is from where to where, from here to here is a one node, and here this is from here to here is one node. Okay, now, so if I have already told, if there are three nodes, one node has to be considered as a reference or a ground. So this is how we apply the KCL. And one more most important application of KCL is we can find the node voltage wherever it is present by applying a KCL. And what is the application of KVL? I have told it is used to find the current in a loop. Anywhere you find a loop, you can find the current in it by using the KVL. We can apply KVL here also, but we are studying the KCL, so I will tell you with respect to KCL. So KCL is used to find the node voltages. It's a current law, but we use it to find the voltages, and it's a voltage law, but we use it to find the currents. So Now let me take one ground. So here is a ground. I will connect it here. Okay, this is whole I have considered as a reference. We can consider this also reference, but I will consider this as a reference for the easy. Okay, because if we consider this as a reference, it is going to be a tough for to apply here, because here the minus terminal of battery is connected here, so we have to take minus 1 volt here if we consider this as a reference. But if we consider this as a reference, we can take this as a positive, because positive terminal of the battery is connected this side. So while considering an reference, we have to look it into the we have to go into the easy way. That's what the engineers do. Always look in the simplified way. Means looking in the simplification way is the thing what engineers do always. So now I have took this. Now we will apply an KCL to this circuit first. Let us consider this node has X. Okay. Then we will apply the KCL to this node. Let us consider the current is incoming from, no wait. We will consider the current is outgoing from this node, this side, and also outgoing from this. We can consider whatever we want. But I'm considering the, no, there is a thing, one more thing I have to tell. We considered this node. So this node we are going to consider it as at a higher potential, and we will apply KCL according to that. We'll consider that current is going from this node to here, and from this node to here, and this node from to here, the current direction we are considering. So now let us apply the KCL. So this, with respect to this node, if we take, we are made it as a x, to let us take it as Vx minus 1 divided by 1. This is what Ohm's law. What is Ohm's law? V equal to I into R. So I is equal to what? V by R. What is V? Voltage difference. So what is voltage difference here to this resistance is that Vx minus 1 divided, Vx minus 1 is the voltage difference, and R is the resistance value, that is R1. So Vx minus 1 divided by R1, what it is? Current through this resistance. And now let us continue the KCL. So Vx minus 1 divided by 1 means R1 plus, what is the KCL? KCL is what? Sum of the entering and leaving the current at the node is equal to 0. Means current at the node is equal to 0. Total sum of current at the node is equal to 0. What is the KCL? So here we have considered this current. Now let us consider this current. So this current is going to be again Vx minus 1 divided by R2, and this current is going to be Vx. So we have considered this as 0. So Vx minus 0 divided by R3. So what is the total equation is going to be? So total equation is going to be Vx minus 1 divided by 1 plus Vx minus 1 divided by 1 plus Vx by 1 equal to 0. So totally by simplifying, we are going to get it as 3Vx equal to 2 and Vx equal to 2 by 3. That's what we are going to get the value of voltage at this node. So voltage at this node is going to be 2.2 by 3 by, means 2 upon 3 volts. That's nothing but 0.66667 volts. That's the value of node voltage there. So we have found the theoretical value. Now let us put one probe and see is it correct or not. So probe is here. So here is a probe. Let me take the, here I have took the voltage probe. So let me connect at this node. So this whole thing is a node. We can connect it here, 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 anywhere, which is going to be the same. To show that also I'm going to connect it. I have connected here. So at this all three probe, the same voltage is going to come, because from here to here is one node. Okay, let us run it. So our theoretical calculation is very correct. You can see the value 0.6667 volt, and all these three values are same because it is a same node. Okay, you can put a very complex circuit also I have thought it by using a very simple circuit so that you can understand it very easily. And if you want very big circuit, you can do it, but use the Proteus software, which is beautiful software to understand the any concept of electrical or electronics. You can also simulate the electronics part of it. Okay, that's it for today. Thank you. And if you like the video, please subscribe my channel, like, share, because it motivates me to do more videos. I know I am irregular to uploading the videos, but now onwards I will try to be regular. Okay, that's it for today. Thank you.